So let me try to make clear what my answer is that everything can easily be derived from the Lorentz transformations, and there is no mystery to it. My first statement here says if you have an object receding from you at near the speed of light, it will appear to be moving at a maximum of 50% of the speed of light. And I said, why? Answer this question for yourself, and if you agree, upvote. If you don't agree, downvote, and post a comment. So let's go out to Wikipedia's article on the twin paradox. Or more specifically, let's go have a look at the talk page. So you'll see on this talk page that the talk archive has been archived on the twin paradox 14 times. So I'm going to search the archives for my Wikipedia username, jdoolin, and you'll see that I commented somewhere in archive 13. And let's just get into the messiness of this. You can see that I asked whatever happened to W. Wood's diagram and why isn't it in the article now? So let's go back to the file history before that fourth view was added. So here's the diagram of the 3 relevant reference frames posted by W. Woods. Okay, so here we have these 3 events A, B, and C on which are measured to be simultaneous with the turnaround event E, depending on whether you're in Earth's frame, where B is simultaneous with E, or the outbound frame, where A is measured as being simultaneous with E, or the inbound frame, where C is judged simultaneous with E. But I'm not concerned with what events are simultaneous with event E. I am concerned with what is literally seen by the traveling twin during the turnaround event E. So let's introduce yet another event to the scenario called event F, which will be what is happening on Earth that is observed by the traveling twin during his turnaround. You can determine that event by imagining that the speed of light, which is the same as this slope here, I probably drew it wrong, but those should be parallel lines in each case. We don't have that direction labeled on this graph, but it should be parallel. Essentially a 90-degree angle from here to here, so it should be parallel with that event, or to that kind of where that intersects there, F, and then do the same thing here, parallel to that dotted line there, and we'll have F down here. Okay, so this is the event which will be happening on Earth that is observed by the traveling twin during his turnaround. Now, here's what I consider to be the most overlooked point in the twin paradox. The distance that the traveling twin sees the Earth recede on his outbound trip, marked here, is far, far less than the distance that he sees the Earth approach on his return trip, marked here. At most, this delta x, delta x delta t from of event O to F can be at a maximum of 0.5 times the speed of light. But over here, this delta x delta t from this delta x delta t from wait, is it OF? Yeah, from OF. Is it OF still? No, I used the wrong delta t. I'm sorry. Over here, we'd be looking at this delta t and this delta x. And over here, we're looking at this delta x and this delta t for the apparent apparent speed of the object. And what I'm saying is this delta x delta t going this way is limited to less than half of the speed of light. But this delta x delta t is unlimited. It could go up to infinity if this object was approaching close enough to the speed of light. But my main point here is that during the acceleration, the traveling twin will see the Earth, which is over here. This is the image. This is where the image of the Earth event is. This is where its distance is. He'll see it lurch back in space from that distance all the way to that distance. That happens like instantaneously in his perspective. That distance will suddenly change. The Earth lurches back. And then the associated event, F, right here, lurches backwards in time. So it goes from here, which is almost practically simultaneous with E, it goes all the way down to there, which was before his, which from his perspective is before he even left. It launches like the Earth is going to be approaching for longer than his trip has been so far. So anyway, my point is, you have to mix and match these frames to really understand what the theory says and what the traveling twin observes. If you fully take into account what the time dilation, what the traveling twin observes from here to here, and then add on to that, to this event F that he actually observes, and then go from that event F to that event D, taking into account how far the Earth moves and the velocity and everything, then you should find that this will give you the actual age of the Earth, or how much the Earth aged, after you take into account the time dilation as well. If you choose the wrong event, if you chose A, B, or C, then of course you'd get the wrong answer. But if you chose the right event, event F, then you would get the right answer. Thank you for watching.